Hi, welcome back. In the previous module, we got an overview of automated testing, we learned a bit about xUnit.net, we went and created an xUnit.net project, and we started to write our first test. We saw that our first test was incomplete, however, because we haven't yet added an assert. In this module, we'll go and complete this first test, and we'll also learn about the different types of asserts that xUnit provides. We'll start off this module by getting a brief overview of the concept of asserts, and we'll also discuss how many asserts we should have per test. We'll then head into the code and we'll write a number of additional tests. These tests will demonstrate how to assert against Boolean values, how to assert against string values, including more advanced versions of string-based asserts, such as checking against regular expressions. We'll learn about numeric asserts and how to deal with floating point precision. We'll see how we can assert that a value is null, and a number of different ways we can assert on collections, such as checking a collection contains a specific item. When we're writing asserts, we can also check that an object is of a specific type, and also that two object instances are equal. We'll learn how we can assert that an exception is thrown at the correct time, and also how we can assert that an expected event was raised. So let's kick off this module by getting a brief overview of asserts. So what do asserts do? Well, asserts evaluate and verify the outcome of a test based on a returned result, final object state, or the occurrence of events observed during execution. An assert can either pass or fail. If all asserts pass, the test passes. If any assert fails, the test fails. xUnit.net provides a wide range of assert functionality for different types of results. For example, we can assert that Boolean results should be true or false. If we're asserting against string values, we can check that the result is equal or not equal to an expected value. We can assert that a string should be empty, and that it should start or end with a specific string. We can also check that the result contains an expected substring. For more complex string asserts, we can also check that the result matches a regular expression. When it comes to asserting against numeric values, we can make asserts based on equality or inequality. We can check that a returned result is in a given numeric range. And we can also optionally specify floating point precision in numeric asserts. xUnit.net provides a number of ways we can assert on collections, such as checking that the contents of a collection is equal to an expected collection, asserting that a collection contains or does not contain a specific element, checking that a collection contains an element that satisfies a specified predicate, and checking that all items in a collection satisfy a specified assert. We can check the code we're testing raises events as expected, so these could be custom events or framework events such as the property changed event from the iNotifyPropertyChanged interface. We can also write asserts to check that the result is of a specific type, so we can assert that the type should be an exact match, or that it can also be a derived type. A test should have at least one assert, but how many asserts can we have in an individual test method? The most strict school of thought says that we should only ever have one assert statement per test. So for example, if we have this test here, where we're testing the sleep method, we're asserting that after the player character has slept, their health should be within an expected range. This test currently has a single assert. A more moderate school of thought suggests that we can have more than one assert in an individual test method, as long as those asserts are testing the same behavior. So if in this example we were to add an additional assert, checking that the player character's isNoob property is set to true, then this assert has nothing to do with the behavior we're testing, namely that a player character should increase their health after sleeping. It's got nothing to do with the isNoob property. So this is an example of a bad use of multiple asserts in a single test, because the assert.true method is testing a completely different behavior to the assert.inRange method. So here we are back in Visual Studio. Let's see how we can use Boolean asserts now. So here's our test from the previous module, and notice we don't currently have an assert. In this test, we want to check that when we create a new player character, the isNoob property is set to true to indicate that they're an inexperienced player. To do this, we can use one of the xunit.net assert methods. So let's come down here to the test, and we want to assert that the isNoob property is true. So here we're using the assert.true method. Let's go and build this, and we'll use Test Explorer to run this test. I'm just going to right click and choose Run. The test will execute, and we can see that the test passes. If we were to change this assert to assert.false and run the test again, we can see now that the test fails because we're expecting a value false, but we actually got back a value true. So the assert.true and assert.false methods allow us to check simple Boolean values. Let's just fix this up and run the test again, and it should now pass, which it does. Let's see now how we can assert against string values. If we take a closer look at this player character class, notice here that we've got this first name, this last name, and also this full name property. This full name property returns the first name appended with the last name, separated by a space. So let's write a test to check that the full name property is working as expected. Let's head back to our test class, and we'll add a new test method. We'll start with the xunit fact attribute. We'll create a new test method called calculateFullName, and we'll start off by creating an instance of our system under test, our player character, and then we're going to go and set the first and last name properties. So let's set the first name to Sarah and the last name to Smith. We now want to make our assert that the full name is correct. So in this case, we're going to use the assert.equal method. This method takes two parameters. The first is the expected value, and the second is the actual value. So here we're expecting that the full name is going to be Sarah Smith, and the actual value is going to come from the full name property of our player character. Let's build this, and head to Test Explorer, and we can see our new test here. If we right click and run this, we can see that our test passes. If we were to go and introduce an error, so let's head over to our player character and let's just go and remove this space. We'll build this and run our test again. Our test should now fail because the expected value no longer matches the actual value. So we can see here we expected Sarah Smith with a space, but we actually got Sarah Smith with no space. Let's just go and fix that up, and run the test again, and the test passes. If we just wanted to check that the full name property started with the first name, instead of using the assert.equal method, we could instead use the assert.startWith method. Once again, this takes an expected value, in this case Sarah, and then the actual result, once again our full name property. If we build this, and we should see the new test show up here, we can run this new test, and as expected, the test passes. There's a method that complements starts with, and that's the ends with assert method. As its name suggests, this assert is going to check that the full name ends with the string Smith. Let's build this, and head to Test Explorer, and this time we'll just run all of the tests. We can see here that our new test is passing. If we're writing asserts against string values, but we don't care about the case, we can add an optional parameter to the assert.equal method. So let's go and add a new test here. Notice here that we're setting the first and last name in uppercase, whereas the assert.equal is using the lowercase version. If we build this and go and run this new test, this test will fail because by default it's a case-sensitive check. We can see we expected Sarah Smith lowercase, but because Sarah Smith was uppercase, the test fails. If we don't care about the case sensitivity when comparing strings here, we can add an optional parameter. This parameter is the ignore case parameter, and we can set this to true to tell XUnit that we want this test to pass regardless of the case. If we run the test now, the test should pass because it doesn't matter what the case is. In addition to the assert.startsWith and assert.endsWith methods, we can assert that a string contains an expected substring. So let's add another test here. Once again, we're setting the first name to Sarah and the last name to Smith, but this time we're using the assert.contains method, and we're just asserting that the middle of the string contains the letters AH with a space, followed by SM, the first two characters of the last name Smith. We'll go and run this new test, and this test passes. There may be occasions when you need to make more complex asserts against string values. To do this, we can leverage the full power of regular expressions by using the assert.matches method. This assert.matches method takes a couple of parameters. The first parameter is the regular expression itself, and the second parameter is the actual value. So if the full name matches this regular expression, the test will pass, otherwise the test will fail. This regular expression is going to check that we get an uppercase first letter for the first name and an uppercase first letter for the last name. Let's build this and run this new test. And we can see because the regular expression matches, the test passes. If we were to go and change this, so for example to a lowercase s, and run the test again, the test will no longer pass, because the regular expression no longer matches. And here we can see the failure message is telling us that the regex doesn't match the value. Let's just fix that. And we'll run all the tests again to check they all pass.